We talk about the internet like it's magic. We imagine our data living in a weightless, invisible cloud floating somewhere above us. But when you type a web address, you aren't sending a signal into the sky. You are firing a physical pulse of light down a tangible glass wire. That light zips out of your house, travels down your street, and merges onto massive underground highways of cables stretching beneath your city. Welcome to Nimbica. If you're visiting a site hosted in another country, your request literally crosses the ocean. It travels through thick, heavy submarine cables laying directly on the sea floor. And the final destination for that journey? A physical computer, just a machine sitting in a cold, loud room somewhere in the world, waiting to hand over a website. Because the internet is made of physical materials, it is bound by the laws of physics. That means your data can only move so fast, and it is entirely limited by the harsh reality of geographic distance. Let's say a business runs their website off a single, powerful computer located in Toronto. If you live right there in Toronto and try to visit that site, your request only has to travel a few miles. It's a very short physical commute, so the page loads on your screen almost instantly. But what if a customer in Tokyo clicks that exact same link? Their request has to cross the Pacific Ocean, arrive in Toronto, pick up the website data, and travel thousands of miles back to Japan. That long round-trip physical commute takes real time. To make matters worse, traditional servers have to think. Every single time a visitor clicks a link, the computer has to dig through its files, run code, and build the web page from scratch before sending it back. We call this live computation. If 1,000 people from all over the world click the link at the exact same moment, that single Toronto computer gets overwhelmed. A massive queue forms. Everyone has to wait in line while the machine builds the pages one by one. A traditional single server setup guarantees delays. Distant customers are forced to make a massive geographic commute, only to get stuck in a processing traffic jam when they arrive. To solve both the distance problem and the traffic jam simultaneously, engineers created what is called an edge network. Instead of forcing a computer to build the page from scratch every time, the system takes a single finished snapshot of the fully rendered website. We call this a static copy. The system takes that finished snapshot and distributes it to hundreds of smaller, specialized computers stationed in cities all over the world. Now, when our customer in Tokyo clicks the link, their request doesn't cross the ocean to Toronto. It connects instantly to a small computer sitting right there in Tokyo. And because that copy is already completely finished, the local computer doesn't have to do any live computation. It doesn't think, it just hands over the file right away. By placing pre-built data physically closer to the user, at the edge of the network, you completely eliminate the long geographic commute and entirely bypass the server traffic jam. When you remove distance and live computation from the equation, websites that used to take 3 or 4 seconds to load suddenly appear on your screen in a fraction of a second. Nimbica is a platform that brings this exact global distribution architecture to traditional, heavy websites. This dashboard shows the Nimbica plugin in action, right at the moment it generates a static speed cache. It creates that optimized, pre-built snapshot we talked about. This mobile performance report shows what happens next. The site earns an incredibly high 97 performance score, and the page paints onto the screen in under 2 seconds. Looking at this desktop diagnostic, you can see a mathematically perfect score of 100. Notice that the total blocking time is 0 milliseconds. Because the server isn't building anything from scratch, there is 0 waiting in line. This independent GT metrics report confirms the exact same outcome, awarding the site a grade A and a 99% performance rating. It is a consistent, structural result. The underlying wires of the internet are inherently incredibly fast. Slow websites only happen when we force our data to commute. By putting ready-to-go data on the edge, that wait is permanently solved.